necessarily need to cause bodily injury by hacking the train. You just need to change the message to say, ladies and gentlemen, there is a X on this train. Now you have 1,000 people panicking in tunnels.
Welcome everyone to the Industrial Security Podcast. My name is Nate Nelson. I'm here as usual with Andrew Ginter, the Vice President of Industrial Security at Waterfall Security Solutions. He's going to introduce the subject and the guest of today's show. Andrew, how are you?
I'm well, thank you, Nate. Our guest today is Shannon Ramsaywak. He is a managing partner at Nathanial Rand, and our topic is cybersecurity for rolling stock. And as you'll probably figure out in the course of the discussion, rolling stock is a very old railway term for, well, trains.
Hello, Shannon. Before we start, can you say a few words about yourself and about your role at Nathanial Rand?
Sure. Thank you for having me, Andrew. I'm one of the managing partners here at Nathanial Rand. We are an IT and OT cybersecurity firm. I started my career as a network engineer from the ground up. I went on to build the security program at the MTA Long Island Railroad, where I spent about 14 years as the CISO in that organization. I left and I became the CISO CTO of Kind Snacks, building out their security program from scratch, building out their digital platform, including securing their manufacturing firms across the globe in their OT environments as well. And after 3 years, I actually left. I went to NBC Universal, and I was the head of enterprise security for global shared services, where I spent 2 years securing the corporate shared service enterprise across the NBC Universal global spectrum. I've spent about 2 years there until recently coming back into the IT, OT, operations, technology, security space here at Nathanial Rand and taking over as one of the managing partners.
Cool. So you've got a little IT, you've got a little OT. Our topic is cybersecurity for rolling stock. We're talking trains, railway systems. Can we start, by getting an understanding? Can you explain what are the physical systems we're talking about? What are the pieces? How do they work together?
Sure. So, one of the common terms that we use in the industry is rolling stock for the trains themselves, but they're part of a larger ecosystem. And specifically for this conversation, that ecosystem involves obviously having the trains and its controls and everything else, which we'll get into a little bit later, but also the signals, the switches, the public information display systems, train timings, the TVMs, the ticket vending machines. So those are all the components that kind of come together to make the infrastructure work. Specifically today, we're going to talk about passenger trains in the regional rail transportation and the local inner city subway system transportation. That usually consists of electrified cars and trains that move passengers along the right-of-way. Those components still remains to be pretty much the same. Internally on the cars themselves, you have the positive train control or computer-based train control, PTCs, CBTCs. On the tracks and the signal systems, you have the computerized systems in there that allows for the train to receive the signal to move forward or not. We can get into more details on that. The switches, which are the interlocking that allows the train to switch from tracks to track. The customer information systems, which is like the announcement systems on the trains itself, the signage, which is a very, very critical part in the cybersecurity world. And that's about it.
You mentioned signage. Signage telling passengers where the rails are, is this part of the connectivity question? I'm going to ask you about connectivity in a minute, but signage specifically is something I'm interested in. People's cell phones need to know where the trains are. The signs need to know where the trains are. Is this kind of connectivity part of the cybersecurity issue that we're dealing with here?
Partly, but there's a larger issue. The connectivity issue really talks about the ability for people to be able to commingle the data, and in that being able to hijack the communication. And the most critical part of that is hijacking the information. So think about it. Here in New York, you have the commuter rails during rush hour holds about 100 people per car. A train itself would have anywhere between 8 to 14 cars. That's anywhere between 800 to 1,400 people. Now, the signage itself on the train and in and around is very important, because if you were able to hack that sign, or you're able to hack the train announcement systems, or you're able to hack the display systems on the train itself, you don't necessarily need to cause grave bodily injury by hacking the train. You just need to change the message to say, ladies and gentlemen, there is a X on this train. Now you have 1,000 people panicking in tunnels who have the ability to pull the mechanical emergency lever to stop the train, get off the train. Now they're on the tracks in these tunnels outside that has electrified third rails, 700 volts, plus other trains coming on different tracks causes a great amount of a complex issue.
What struck me in his description there was the signage. I mean, I'd always thought that if somebody messes with the signage, you either A, embarrass the company because there's a taunting sign up, or B, confuse the riders, the passengers, because they're, getting on the wrong train and wind up in the wrong city and are really unhappy. But it never occurred to me that signage was a safety threat. So much of the rail system is about safety. That's, I guess, one of the lessons from the whole episode here is that a lot of this is about safety, much more so than even occurred to me when I was coming into this.
When I picture trains, I'm sort of holding two images in my mind of one, older rail lines versus newer like subway systems. Are we talking about both? Are the systems similar enough that we can be talking about both at once?
In my understanding, what we're talking about here, Nate, is metro and commuter rail systems. So reasonably local. They might still be intercity, but I think they're all electrified.
Okay, electrical, but can you be more specific, Andrew? Because as a New Yorker, I have some experience with subway lines that are both modern and not modern. To my understanding, or at least the latest that I've read, the New York City subways, some of them are new and they're implementing new signal systems, but a lot of the signaling systems are still what's left over from the 1930s. So there's a sort of mishmash of electrical and the old. So could you be more specific about exactly what kind of tech we're talking about?
Yeah, so we're talking about all of it. I do ask Shannon a little bit later on about, what happens with legacy systems. And I can't comment on what kind of system the entire New York Metro uses. I guess what I'd caution you is that even if parts of the signaling system, are or appear to be sort of older analog systems, I would be surprised if you don't also find computers in the rolling stock. And we're not really talking about the signaling systems, which is the way you switch tracks. We're talking about what happens inside the trains, inside the rolling stock. We're talking about the automation inside the trains. If we want to talk about the signaling systems, we need another expert. So I'm if there's people out there, give me a call. We'd love to understand more of this problem and the cybersecurity issues.
We're heading for industrial cybersecurity, which implies computers. Can you explain, the physical trains? How are they automated? How are they connected? Where are physically these computers? What do they do? How do they relate to each other?
Sure. So let's look at it in three categories logically, not physically. Physically is where the issue is, right? So logically, there are three parts to the way the systems are set up. One is it's the critical controls like air brakes, moving forward, positive train control, CBTC. Then you have the wayside data, train timing, where it is, GPS location. And then also you're starting to see now on commuter rails the ability to be on the Wi-Fi network to be able to provide that extra level of comfort for passengers. So logically, those are three. What's happening is the ability to commingle. So the first one is where you absolutely do not want anyone commingling any type of data in there. Are there instances of it happening? Yes. And that is being retrofitted and cleared up by some of those older networks. But going forward, the way that new trains are being designed, they're actually beginning to try to separate those as much as possible, if not physically, logically, by having like a data diode or a unidirectional gateway. And the reason why is because space is such a premium on these trains themselves. In the electric passenger rails, each car has propulsion or quote unquote an engine. It allows each car to become the driver. So usually trains are paired up into an AB pair. An AB pair would have, the two pairs would then have additional cars attached to it to make a train. And when a car or a train pulls into a particular station, instead of turning the train around, the engineer would just go to the other end, which if they started on the A side going into a station, they would go back to the last car, which would be a B train, turn the train around. So each car needs to have propulsion because you can basically time and pair them up everywhere. That being said, space is a premium because of all of the electronics that need to be on board for those three networks and those three systems. With space being a premium, you're starting to find companies that would look at consolidating as much as possible. In the cybersecurity world, it makes our job a little bit more difficult, especially when you're commingling the information across the board. Again, this is why, if it must be done, having something like a unidirectional gateway or data diode or whatever you want to call it in between is so very important.
Help me out with something. I didn't quite follow this notion of there not being enough space. What is it about a train that wouldn't lend itself to space? I've never met a small train in my life.
That's a good question, and that actually surprised me in the interview here. I'm a little bit familiar with freight systems because at Waterfall we've done some work with those systems, and in those systems, it's the locomotive that is heavily instrumented. There's minimal instrumentation throughout the rest of a freight train. What surprised me was that here, every car is a locomotive in the sense that every car can have an engineer sitting in it running the entire train. And so you need all of the instrumentation for the entire train, all of the instrumentation that a locomotive needs in each and every car. And now you can imagine that space becomes a premium because you also want space for luggage and passengers and the engineer, the driver, in every car.
I see. And what is the reason that you need the locomotive in every car? Can't you just have it in one or two?
In principle, yes, but and I didn't ask Shannon this question, but in my understanding, these cars are expensive. They cost millions or tens of millions. I don't know. They're very expensive, for consumers by my standards. And so it's my understanding that the railway, the metro wants to maximize the value they get out of each of these cars. And if they're constrained in terms of, well, these cars are locomotives, those cars are not. When I come into a station, now I have to, shuffle my cars so that I can make up a new train to go somewhere. That costs you time, and and the time that the car is not in use carrying passengers is lost opportunity. So they've designed this system so that every car can be the lead car. And he talked about A-B pairs, where you put these cars, one of them facing forward and one of them facing backward. And now imagine a train only has those two cars in it. The driver can can pull into the end of the line, walk to the other end of the train, the two-car train, get back in and drive away. Or you can pull into a station where you're going to split and half the train goes to one city, half the train goes to another city. You've often seen this on the signs that say, if you want to go to this city, get in the last 6 cars. If you want to go to that city, you got to get in the front 4 cars because they're going to split. And these pairs of cars can take off and you have maximum flexibility. You don't need a switching yard to turn the train around or to rearrange the cars and the locomotive. You just pull into the station and you pull out and you go your own way. It gives you flexibility for these very expensive assets. But now it means all that instrumentation has to be jammed into each and every car.
I see. And the cybersecurity issue here is that we're dealing with a lot more computers, or that there's not enough space for them, or what?
We talk about that later on, so let me defer the answer on that. But the key word there is commingling. When he starts talking about commingling, this is the cybersecurity problem when you have a lot of functions that now you want to jam into a smaller number of computers, and some of those functions are safety critical, and some of them are not. So let's get back, and we'll get to the commingling part in a few minutes.
You mentioned positive train control a couple of times. Can you dive into a bit of detail on that? What is positive train control?
Positive train control is what a train receives information regarding its location, where it is, and how it's allowed to proceed safely. There are 2 parts to this. One is the actual computer-based part of it, and the other one is the human interaction, the positive aspect of it. So the train would normally receive its signal to tell it that it can continue to go forward from central control based on the location, GPS location, based on what area of the track it is, and also with the interaction with the engineer every 30 to 60 seconds to let the train system knows that the engineer is still conscious. They're still able to perform any manual intervention.
That makes sense. That agrees with what I've read elsewhere. Positive train control seems to be sort of something new that everyone's being pushed to implement. Is positive train control the newest? Is it sort of the state of the art?
It's more of a category. The newest is CBTC, and CBTC has even a newer version, which is wideband. So CBTC came about back in the early 90s or so. It's computer-based train control that rides off of analog radio waves. And whereas traditional positive train control has a limited amount of information on the trains themselves, CBTC overlays a lot of the technology throughout the train, but as well as on the tracks in different locations to have a lot more tighter pieces of information. In CBTC world, you'd be able to tell the location of a train within centimeters of where it's actually located. In traditional PTC, you have a general idea of where the train is. CBTC also uses GPS, like live GPS itself, to be able to tell the exact precise location where a train sits on a particular area of the track. Tracks are usually broken up in 1,000-foot blocks, and those blocks would use to tell the trains whether or not within 1,000 feet, if another train is ahead, stop the train behind from coming in. With CBTC, you have a lot more efficiency in where trains can be and how close they can be without having to go through all those concerns. The next iteration of CBTC is going into ultra-wideband, which is a lot more precise, and it gives a lot more coverages through different geographical locations where radio waves can't really go through. So the technology has progressed at light speed in securing the trains and their locations and their positions.
At Waterfall Security Solutions, we are the OT security company. To help customers and other industrial owners and operators in this difficult time, Waterfall is extending our free remote screen view license program through the end of 2020. Unidirectional Remote Screen View is the most secure remote access possible for industrial sites. The design of Waterfall's unidirectional security gateways enables remote support while physically preventing any remote attack from reaching back into the protected network through the gateway's protective hardware. For details of the program, please visit the Waterfall Security Solutions website or reach out to your host at andrew.ginter@waterfall-security.com.
So, Nate, what I got out of that is that the world of computer, let's say, automation or computer control of trains is evolving rapidly. I mean, in the past, my understanding was that a lot of the signaling systems relied on the engineer to see the signals and respond appropriately. And there had been incidents when the engineer, with human error, made a mistake and trains crashed and people died. This was very bad. And so my understanding is that positive train control came in as a way to computerize that. A train is now allowed to proceed, allowed to continue operating only if both the engineer responds to the signals and if the train gets sort of a computer okay from the main operations center on a regular basis. If either of those fail, that's the positive thing. If either of those don't happen, because let's say, the engineer had a medical emergency, the train automatically slows down and stops. The computers stop the train. And my understanding is that, this computer-based train control, the newest stuff, is even more of that. It's even more accurate. It's even wider coverage for the wireless communications. So the field is progressing rapidly. And it's a little confusing because it's my understanding that, this stuff, positive train control, the CBTC, it's not necessarily one technology. It's a family of technologies. It's a family of approaches to how this stuff works. So trying to nail down the technology by, going to Wikipedia or something can be really quite challenging because there's such a wide variety of stuff within each of these umbrellas.
Yeah, right. I can only speak to my personal experience as a New Yorker. In our system, the overwhelming majority of trains run according to block signaling, which is basically you define a certain distance that you attribute to a block in the system, and if a train car enters it, then the signal reflects that, and if the back of the train, the last car, exits a block, then you signal that as well. And that's sort of how you tell where a subway is in the system. It's sort of a broad, vague notion that it's approximately, where it is. Whereas the line that I use for the most part due to where I live has had CBTC implemented for, I think, a number of years now. And before the construction got pretty bad on it, so I don't want New Yorkers getting on me about this, the line with CBTC, at least in my non-technical view, was much faster and more reliable and more predictive of when, or rather better at predicting when the trains were going to arrive in the station, as opposed to the block signal lines. So I can tell from personal experience how effective this sort of Wi-Fi signaling can work in these systems.
You've mentioned the consequences of compromise if someone messes with the displays in the wrong way. Can you talk about the computer systems more generally? What are we worried about? What are we trying to protect here?
The very first thing that we're trying to protect is human life, right? Because the trains themselves are a tool to move thousands and thousands and millions of people across the nation altogether. But we're really trying to protect human lives. And if the systems are compromised in certain ways, it can adversely affect that. It can affect the cost of a human life.
It makes perfect sense that, safety is the number one priority. But in my understanding, you were talking about computers, everything from, consumer Wi-Fi, reaching out to the internet while they're traveling on the train, all the way through to, controlling the position of the train, the safety systems, the signage, the whole thing. What are the, safety is the priority. What are the security concerns? Why are we worried?
Well, we're worried because of the new interconnectedness of everything nowadays. So recently in New York, there was a mandate by the executive branch that all OT networks need to be monitored by the IT departments. So that's one thought bubble. The other one is when you think about what happened recently with COVID and everything else, ridership in New York was down between 70 to 90%, depending on which line, which either subway or rail line that you're referring to, companies are starting to look at other ways of improving revenue, which means that they're looking at improving the customer experience. I could only imagine what the whole new world is going to look like, having a lot of remote companies allowing people to work remotely. Ridership might be down. So railroads and subway systems are going to look at enhancing, or they're already starting to look at enhancing the customer experience. That being one of the most important part is an interconnected world that we live in, and allowing them to be able to still have their phones and their laptops and all that interconnectedness. So those two thought bubbles, where you have the IT world, mixing into the OT environments, causes a lot of opportunities for breach. And if not done correctly, we would have great concerns of having these operational technologies, in this IT world being compromised.
So I understand what Shannon's saying there. From my personal experience, I wouldn't put too much stock in the effects of COVID lasting that much longer. Recently, having ridden the New York City subways myself, I was quite surprised at how relatively normal it felt. You wouldn't know, other than the masks, that there was a pandemic. So my thinking is that once all this is over, things might actually get back to normal.
And you might be right. I think Shannon's point was that rail system operators, passenger rail system operators, have been focusing increasingly on the customer experience in the last several decades, and he expects that trend to continue. His point was that COVID might accelerate that. Yours is that it might not, but the trend, I think, is going to continue, and a lot of that trend to improved customer experience has to do with computerization.
I see. And to that point, I did have a question regarding the IT and OT connectivity here, because we're talking about how many more computers we're installing in trains. But are the computers that allow for Wi-Fi in a train car really connecting to the ones that are doing operational things?
That's a good question. And in a sense, that comes back to your commingling problem and the space problem question earlier. We're leading into an example here, and Shannon goes into detail on all those topics. So let's listen in.
Can you give me a concrete example of what we're worried about?
Yes, absolutely. So it actually ties into two of the things we spoke about, signage and customer Wi-Fi. So one of our clients recently, when recently in railroad terms is about 2 years ago, because that's when the design was starting to happen, asked us to be a part of their security review in designing the new railroad trains. The customer service department and the engineering department wanted to offer Wi-Fi to all the customers on the trains themselves. Now, how that's done is complicated as it is, because you have to have cellular antennas on the trains themselves, and you have to make sure that you have the right cell coverage along the right-of-way. In places that are densely packed and small towns like New York or California, each town would have their own zoning rights for cellular service, and it could be a little spotty, but that's a different issue. But because of the lack of space that we talked about earlier with all the technologies going on, the initial design was to commingle the wayside data, which included signage and notifications, customer notification, with the Wi-Fi network, to be separated by just a switch or a router via an SD software-defined network, which we know is right now might be secure enough, but these trains are in production for 20 to 30 years, and eventually that's going to deteriorate. Someone's going to find a way around it. The only way that you can actually protect a system like that is to have a physical device in between the networks themselves. And in the case of what we recommended was a UDG. In this case, it was actually Waterfall that we recommended if they're going to do this. The operating departments didn't understand what we meant by that. So what we did was, in one of the test networks, we actually hacked through the Wi-Fi and was able to get into the display systems. We changed the message to say, ladies and gentlemen, there's an on this train. And that actually got the attention of the 150 plus engineers and architects and designers and customer service people in the room. And it actually got them aware enough to know that we should not be doing this right now, at least on these new trains that are going out, until we find a better way of securing this type of environment going forward, because we didn't have the space to separate it or the space to put another device like a waterfall in there.
So a lot of that made sense to me, but I did have one question about something he said. Shannon said that essentially you need not just software to separate the IT and OT systems on the train car, but a physical block to separate these networks. Now that makes sense to me. We talk a lot about the need for physical safety measures, that firewalls aren't just enough. However, why do you need any kind of block between these two systems? If I'm picturing, machine X does the operational stuff for the train, machine Y gives the train Wi-Fi connectivity. Why, in any sense, would these systems be connected at all in the first place?
That's a good question. I think the answer is space. So in Shannon's example, there's only so much space for so much equipment in each of these cars, and they had maxed out the space. So if they want to get Wi-Fi going, they had to share some of the communications components between Wi-Fi and something else. And what they thought was sort of the least consequential, the easiest to share, was the signage systems. And then, they demonstrated the hack and said, we put up a very dangerous message on the signage. And they said, oh, crap, it's not safe to share these systems. And we don't have room to put, a physical divider, a unidirectional gateway in between. And so they dropped it. And they said, for this generation, we're not going to do this. We have to fix it in the future.
Interesting. Now, space continually is the issue here. I can see why space would be a problem if you're running like the London Tube or the New York City subways. But if we're talking about, for example, Amtrak or any train that runs above ground, I still don't see why space is such a big deal. Why don't you just make larger trains?
That's a good question, actually. And I think that's the one I asked him next, is how we fix this. So let's listen in.
Coming to the bigger picture, though, not doing something, not providing a certain feature because it's too dangerous in the short term, or because we don't have an adequate security solution in the short term, it sounds like a short-term fix. In the long term, connectivity is going to continue to increase. The pressure for new features is going to continue to increase. What's the solution in the long term?
Great point. So, not offering something is just not going to be the case in this interconnected world that we're getting deeper and deeper into as the years come on. And I see organizations starting to engage cybersecurity much earlier. So with the last client, we got there a little bit too late, but we're still earlier than we would have been in the past. So we're seeing the progress, and we're certain that in the next iteration, we're going to be there a lot earlier to work from the get-go with the design engineers to be able to facilitate both service and to securely facilitate it. That being said, with some of our other clients right now in the transportation industry, we're starting to see earlier involvement in the DevOps cycle and the DevSecOps cycle and the agile development, and for us to be able to not just tell people what they can't do, but for ourselves to create the solutions themselves ahead of time to be able to get them to integrate it with their design.
So, that sounds good for the future of, new equipment that we're manufacturing to as part of our passenger systems. But you said that, some of the stuff that's in use today has been in use for a long time, decades. I imagine that the oldest stuff is also computerized to some extent. How big a problem is the old stuff in this world of increased connectivity and exposure?
For the trains that have been in production and don't have all the new features that can be retrofitted securely. We're seeing companies who are doing it like that and putting in devices like a unidirectional gateway or data diode in their systems itself. Fortunately, for the ones that cannot facilitate those devices, we're seeing companies who are just saying, look, that's old stock. We can't add these features. We can't do these things to it. So we can't do it securely. So we're not going to really add on these additional features that could cause compromise to them themselves. Subsequently, because of that crossroads of IT and OT, we're starting to see a lot of companies put security technologies on the ICS SCADA networks themselves, because you don't necessarily have to secure a particular device in order to get it to secure. You can secure the environment itself. So we're seeing a lot of environmental protections and environmental securities that may go around the systems in order to better protect them.
So that's interesting. Looking back on the episode here, this is the most I've heard about unidirectional communications in any recent episode, possibly any episode. What's going on with unidirectional in the Rails industry? Is the Rails industry, special somehow?
Well, you should start hearing a lot more about it as you continue to have these great podcasts, because you're starting to now see a crossover between IT and OT, where a lot of CISOs, CTOs in the IT infrastructure or the IT structure are starting to now be asked to provide security, at the very least monitoring, to the OT side. So naturally, the OT side needs to open up to the very least sending data over to the IT side, to their SOC, their SIC, the MDR, whichever they have, and still maintain the security. So the best way to do that is a UDG like Waterfall, to be able to put in place a traditional firewall. What will happen is you put that in place and you're going to have a TCP connection, right? You're going to have a three-way handshake, SIDS and ACK. But even if it's initiated from one side versus the other via a traditional firewall, you have a tunnel that's established. You can go back through the tunnel. With a UDG or like a data diode, you are basically just sending traffic one way, and there is no way to go against the feed. And again, as corporate CISOs, CTOs, CIOs are now asked to monitor and provide security for these OT, these ICS infrastructure, the data needs to come across, you'll start to see a lot more. We're starting to see that across our clients, not just in transportation, but other manufacturing and other SCADA ICS environments.
So we're talking about unidirectional. For the record, let me define the term for anyone who's not familiar with it. A unidirectional gateway, or some people call it a data diode. The best definition out in the industry is going to be from the NIST 882 standard. Defines a unidirectional gateway as a combination of hardware and software. The hardware is physically able to send information in only one direction. It's not physically able to send anything back. And the software, makes copies of servers and moves the data for you. What I took away from the Shannon's description here, he touched several times on monitoring. And we're seeing this at Waterfall in the last couple of years, really, last 24 months or so. A lot of IT groups have started becoming active in monitoring OT networks, in monitoring operations. This really wasn't the case. People talked about this. There were people doing it, but not widespread. We've really seen it widespread in the last 24 months. And Shannon's saying this is happening big time in Rails as well. There's a powerful push to get IT security operations centers to be monitoring the entire company now, including OT networks. The issue that he identified is, in order to monitor these things, you need connectivity with them. And any kind of bidirectional connectivity through a firewall, a TCP connection, lets attack information potentially leak back into these systems that you don't want any attack information leaking back into. So the monitoring imperative, he says, is leading to unidirectional deployments. And one other data point in that space, I follow this space. I try to follow this space. There's a standard that's in draft in Europe right now called CENELEC, CENELEC, CENELEC TS 5701. And I've had a look at the draft standard, and it's almost literally every second paragraph talks about unidirectional stuff. So this unidirectional thing really does seem to be a big deal in the Rails industry, much more so than I've seen in most other industries and most other guidance documents that are put together for other industries.
So this has been great. Before we sign off, is there a thought you'd like to leave with our listeners?
It's great seeing that IT and OT are now starting to cross a little bit, where the OT environments are using the economies of scale of the IT folks and the threat hunting, threat intelligence, the things that the IT folks do really well, which for me says a great deal about where ICS security is going to be, because now you have all these years of experience from the IT side, the security intelligence side, the MDR side, bringing that knowledge into the OT side. So I'm really, really excited to see that cross and that commingling. I'm really excited to see what my future peers as CISOs, CTOs are going to be doing in those new environments, and working together with the engineering departments and so forth.
Well, that was over faster than I expected. I wanted you guys to talk about one of those old interlocking systems and how you could hack it. If I wanted to hack a train, I would just walk into one of those stations, pull one of those giant levers, and send it off the rails. Yeah.
A couple of things. I'm not even sure the levers exist anymore, but that's a different question. The topic here was rolling stock. So we're talking about the computers in the trains themselves. The computers that control the tracks, the switching systems, the computers that control the train stations, these are all different topics. The computers that control the electrical systems, they're all different specializations. And, we were focused here on the rolling stock. I would love to have a guest on the show talking about some or all of these other systems, especially as you point out, the fascinating bits of the switching systems. So this is a call for participation. Anybody out there who is familiar with cybersecurity in that space, give us a call. Let's get you on the show.
Then with that, thanks to Shannon Ramsaywak for speaking with you, Andrew. And as always, Andrew, thank you for speaking with me.
Always a pleasure, Nate. Thank you.
This has been the Industrial Security Podcast from Waterfall. Thank you all for listening.